Welcome to Okonko Academy. In this tutorial, I'll be taking you guys through limits of a function. And under limits of a function, we will look at how to evaluate limits, one-sided limits, and also how to determine whether the limit of a function exists or not. So, suppose we are given a function of this sort. What we are to do, first of all, is to put or evaluate the function at 1. So with this, we are finding the limit as z approaches 1. And so what we do is that we put 1 wherever we find z. This will change as we go along the way because some functions cannot be evaluated at the point where we are finding the limit. And what limit does is that we find how the function behaves around the point that it is approaching. So the whole concept of limit is to find how the function behaves around the point that we are approaching. So with this, we find how the function behaves as we approach 1, right? So because this function can be evaluated at 1, we put 1 inside to get the limit. But some functions cannot be evaluated at some points. So for that one, we have another way of doing it. So let's solve this. So with this, we get 6 minus 3 open bracket 1 plus 10 open bracket 1 squared. So if you do not know how to evaluate a function at a particular point, please do well to watch our videos on functions so you get to understand why we are putting 1 wherever we find z. So that's what I'm doing. So after doing this, we are going to get 13 over 6 as our limit as z approaches 1 for this function. So this means that as z approaches 1 from either the left or right hand side, I'll explain this later, the function approaches 13 over 6. Now let's do same for this function too. So because this function can be evaluated at -2, we can put -2 directly in it to find the limit. So these two can be found as 3 open bracket minus 2 squared plus 5 open bracket minus 2 minus 9. So with this, you are going to get 12 minus 10, so minus 9. Then we get our final answer to be minus 7. Now, sometimes we have functions where we cannot be able to evaluate them at that particular point. So let's test this. Let's test this function. So we are asked to find the limit as x approaches 0. And if we are to put, as x approaches 2. And if we are to put 2 inside this function, we will see that we are going to get 0 over 0. And as we know, this is undefined, right? Everyone knows that this is undefined. And as that matter, we use the one-sided limit to evaluate this limit, or we can simplify this limit and find the value. So I'll use this opportunity to explain the one-sided limit for us. So suppose we have a function. Now I'm using any demi function. I'm just using any demi function. So let's say the function, we want to evaluate here is the x-axis, here is the y-axis. Let's say this is the function and this is the point that we want to evaluate. Now we cannot evaluate the function at 2, right? We cannot evaluate the function at 2. So that will be a discontinuity. So we cannot evaluate the function at 2. So what we want to do is to find the limit of the function as it approaches 2. So we can approach the function on the left hand side, or from the left hand side, and also from the right hand side, and know whether this function, the limit of this function as x approaches 2 really exists. And if it exists, when we take any number less than, so if you are approaching the function from the left hand side, it means that when we take any number less than 2 and we put it in this function, so let's say we take numbers like 1 and 0 and we put it in this function, or maybe for 0 to we cannot evaluate, so let's take another number, so let's say -1, -1 and 1, or let's say -5 and 1. So we take -5 and 1, -5 and 1, and we take any number greater than 2, so let's say 3 and let's say 4, right? And we evaluate these functions at in this, so we evaluate these numbers in this function, right? And we get values that are close to 2, or close to a particular, we always get a number close to a particular point, sorry, not 2, close to a particular point, and that will be the limit of the function. So I solved it here. So we took values like 2.5, 2.1, 2.001, 2.001, 2.0001. Then we evaluated the function at those particular points. So for 2.5, we had 3.4. For 2.1, we had 3.857. For 2.01, we had 3 point something. And we also took values less than 2, which is approaching from the left hand side. Then those ones, we saw that all of them were approaching what, 4. So it means that the limit of this function, right, will be equal to what? The limit of that function will be equal to 4, as x approaches 2 will be equal to 4. Now it's either we do it like this, or we can do it in another form too, right? It's either we do it like that or we do it in another form. So we can also simplify this function. And cancel out some terms in order to make the evaluation at that particular point simple. So let's see how that one too is done. So for this, we can simplify this function. We all know how to simplify a quadratic, right? So we would have to look at terms that when we add, we are going to get the middle one, and when we multiply, we are going to get this. So that will be 6 and -2, right? Yes. So we get x squared plus 6x minus 2x. I'm taking you to GHS, right? Yes. I want you guys to understand. Then we get x open bracket x plus 6 minus 2x plus 6. Then we get x plus 2, x plus 6 and x minus 2 as our simplification of the quadratic. So this will be the upper term. So that's divided by, x minus 2x, right? I just factorized x out from this expression. So that means that this will cancel this. So if they cancel, we are going to get our final expression to be x plus 6. This is x, sorry. X plus 6 divided by x. So if you put, now we can evaluate this function at 2 to find the limit as x approaches 2. So when we put 2 inside this, we are going to get 2 plus 6 divided by 2. Then we get our final answer to be what? 4, as we did for the other side. So we can do this in two forms, right? Then we get our final answer. So after doing this, we know that the limit exists, right? Yes. But sometimes the limit does not exist. So let's say when we found the right hand side limit. So when I say the right hand side limit, it means that when we placed values greater than 2 or greater than our limits, right, inside the function, right, when we had it approaching um, a particular point. So with this, when we place values greater than 2, we saw that it was approaching 4. Let's say when we placed it, we saw it was approaching, let's say 10, right? And when we did the left hand side limits, so this is the right hand side limit because we took values above that particular point. And if you take values below that particular point, it is a left hand side limit. So this is right hand side limit. This is left hand side limit. Left hand side limit. So let's say that if the right hand side limit did not approach 4 and it approached, let's say 10, this is just an example, and let's say the left hand side limit, let's say approach 4. If that was so, we would have said that the limit of the function does not exist. So for a limit to exist, the right hand side limit of that function should be equal to the left hand side limit of that same function. For a limit of a function to exist, this condition should hold. So please note this down, that for a limit to exist, the right hand side limit of that function should be equal to the left hand side limit of that same particular function for it to hold. Thank you for watching this video to the end. Do well to like, comment, and subscribe.